Milli means what? 1,000. Okay. But now, what is an osmol?
The number of particles dissolved in a kilogram of water.
Okay. Let's think about this. Earlier, when I talked about the glucose molecule, did I say that it broke down? No, it stays whole. If I only had this in that solution, it would be 1 osmol. Because this doesn't break down, it keeps the C6H12O6, okay? And therefore, I only have this 1 substance in the solution. So it would be 1 osmol in the solution. But what about this? Would this break apart in the water?
Yeah, I couldn't see what you were before. Is it just NaCl?
It would break, and it would become the sodium surrounded by water molecules, and it would become the chlorine surrounded by water molecules. I now have 2 substances in that solution. I now have 2 osmoles. Does that make sense? Because if this were to have broken apart in water, I would have 1, 2, 3 osmoles, but it doesn't break apart. This does. So that gives me 1, 2 osmoles. Does that make sense? That is something that you will be coming across in your clinicals.
So what's the difference between an osmol and a mole?
Mole is Avogadro's number of something. Avogadro's number is the weight of that substance. So let's say if I looked at sodium, not the chlorine, just the sodium itself, it's roughly 23 grams. If I had 23 grams in that water solution, I would have 1 mole. Does that make sense?
Yeah.
It's based on the weight. Okay? So, osmoles is definitely something that you're going to come across in looking at charts and reports for blood work. All right? So that is going to be concentrations of that substance in the lab reports. Now, something else that happens in water, which is, of course, our bodies, all right? Acids, bases, salts, and buffers. What do you think of when you hear acids and bases? pH. Everything in the body has a normal pH, a level at where it should be. Now, any deviation from that norm is going to affect, guess what? Well, any deviation. So if pH goes up or down, okay, it affects the function of proteins. Proteins do everything. Proteins are the product of the cell. So, blood, pH. Roughly 7.45. Is it a big deal if it goes to 7.35?
No, because the range is 7.35, 7.45.
Okay, Mr. EMS. All right, so let's do a different number, okay? Let's say that the 7.45 goes to 7.8.
Yes.
Yes. Why, though?
Because it gets more of a base, the basic.
It gets more basic, which means those hydroxide ions, the OHs. But how does the number of either the hydroxide ions or the hydrogen ions, which make it more acidic, how do they increase or in what increments do they increase or decrease? It is logarithmic, meaning for every step it moves, it's a 10-fold increase. So going from 7.4 to 7.6, that's 2 10-fold increases in the OHs. And that is definitely an offset of the pH to the blood, which is not good for the body. Going down, if we were to go to 7.2, that's a 10-fold increase of my H pluses, more acidic. And the body, see, here's the thing. The body has to be able to buffer the pH. It needs to be able to balance the pH to the point where it's going to be maintained, for example, in the blood at roughly at 7.45. So we're going to have systems that are going to do that. Now, salts, because they are so important, they're going to have the positives and the negatives, okay? Well, any release of the positives and the negatives, which would happen when we intake our foodstuffs and there's salt, involved, all right? The body has to buffer this immediately because we are adding positives and negatives to the blood, and the body needs to offset this. So the body does have the ability to buffer, and that particular process gets very interesting on being able to buffer these systems. But we're going to stop right there for today, and we're going to look at Lab 2.